All right, so let's think about what our quantum numbers are and kind of do a little mini review here. So we'll say here you want to start off with your principal quantum number. So that's your n right here. So we'll start off with that with being equal to 1. So this tells you the overall size and energy of the orbital. And remember, n equals 1, 2, 3, whatever, integers, non-zero integers. And then after that, we have L, and L is equal to from 0 all the way to n minus 1. So n here is 1, so 1 minus 1 is 0, so this number can only be 0. And this tells you the shape of the orbital. So in this case, L is equal to 0. And then we have m sub L. So m sub L, remember, m sub L is equal to negative L to 0 up to positive L. So this case, L is just 0, so m sub L is only equal to 0. And remember that m sub L tells you the orientation of the orbital and how many orbitals you have. So there's only ever one s orbital, 3 p orbitals, 5 d orbitals, 7 f orbitals. So overall, all of these numbers summed together, we could say that this is a 1s orbital. The 1 comes from n equaling 1. The s comes from this L equals 0. So it's the letter designation of this. So if n equals 1, you can only have a 1s orbital. There's nothing else that you can have. Let's take a look at if n is equal to 2. If n is equal to 2. So remember, L can equal from 0 to n minus 1. So n minus 1 is 1, and then it can also be 0. So L is either equal to 0 or L is equal to 1. When L is equal to 0, your m sub L is also equal to 0. When your L is equal to 1, it can go from negative L to 0 to positive L. So your m sub L can equal negative 1, 0, and 1. And so we say this is a 2s orbital. Again, the 2 comes from the n. The s comes from the fact that this is a 0. And there's only one of them. And you know there's only one of them because there's only one m sub L. So there's only one orbital. This guy down here, we say that these are 3p orbitals. Or whoops, 2p orbitals, my bad. 2p orbitals. Again, the 2 comes from the n. So same thing here. Now, whenever L is equal to 1, the letter you get is p. And then how many orbitals are there? Well, there are 3 orbitals because there's 3 different orientations of them. Last one we're going to do, if n is equal to 3, think about the values of L. L could equal 0, L could equal 1, and L can go up to n minus 1. 3 minus 1 is 2, so L can go all the way up to 2. And so when L is equal to 0, this m sub L has to be 0. When L is equal to 1, this m sub L can be negative 1, 0, or 1. When this L is equal to 2, m sub L can equal negative 2, negative 1, 0, 1, and 2. So this guy right here, we would call this a 3s orbital. The 3 coming from the n, and then the s coming from the fact that there is L is equal 0, right? And how many of them are there? There's only one. There's only one 3s orbital. Next up for this section right here, we call this we call these 3p orbitals, right? Again, the 3 coming from n equaling 3, the p coming from the fact that L is equal to 1. So you just kind of got to memorize those letter designation. How many are there? Well, there's 3 of them. And then finally, this one down here, we would call this a 3d orbital. Again, the 3 coming from the fact that n is equal to 3, the d coming from the fact that L is equal to 2. How many of them are there? Well, take a look at m sub L. There's 5 values possible, so there's 5 orbitals. And then the only other thing you kind of want to keep in mind is there's 2 electrons per orbital, right? One can be spin up and one can be spin down. So this one 3s orbital can contain 2 electrons. These 3p orbitals can contain up to 6 electrons, and these 5 3d orbitals can contain up to 10 electrons. This is something that's going to get a lot easier once we kind of get into the periodic table and later on. We're just laying down the foundation for some really important, some really cool information. And so you can see this kind of picture also represents what we showed up there. Right here, we have this value again is your N, and this value here is your letter designation of L. So like we said here, if N is equal to 1, we only have a 1s orbital. We only have a 1s orbital. And think about the electrons that can go in here. Only 2 can go in here. One can be spin up, one can be spin down, right? Then you think about over here, we've got the 2, the N equals 2, right? There we've got 1 2s orbital and 3 2p orbitals. And as you can see here, 1 2s orbital, 3 2p orbitals. And then here's the 1 3s orbital, the 3 3p orbitals, and then the 5 3d orbitals. And then there's 4d orbitals over here as well that they don't show. So you want to take kind of a look at this picture, and you really want to understand this diagram. And so think about some questions to ask yourself. Why are there no 1p, 1d, and 1f orbitals? Think about what the letters mean, the letter designations of L, and what the allowed values of these are. Another question you can ask yourself are, why are there 3 4p orbitals? Right? Why are there 3 of them? Think about, the values, or what determines how many orbitals you have and what that value is looking like. Another thing you should think about, if N is equal to 5, what are the orbitals? Right? 5s, 5p, 5d, 5f. Is that an option? How many of them are there of each? And then the last thing you want to remember is that m sub s can equal positive 1/2 or negative 1/2. And that means that the electron is either spin up or spin down. The other hint I have for you is to play around with ptable.com. And again, this information is going to get a lot more clear once we start actually talking about elements in the periodic table and things like that. But you can go to this website, ptable.com, just type it in, and then you can see up here, there's this orbitals tab. You want to go ahead and click that, and you can see things kind of change a little bit. And so you want to zoom in and move your cursor. You can see you can move your cursor and the orbital changes, right? So this is what's now, I'm over the 1s orbital, so this is the 1s orbital. And you can tell it's just a sphere. If we go up to the 2s orbital, you can see it's a sphere inside of a sphere. And that kind of darker blue region area, that's the node. That's where you have 0 probability. And then 3s is just a sphere inside of a sphere inside of a sphere, and so on and so forth. You see you get more and more sphery. Here's the p orbitals. You can see there's no 1p orbital. The p orbitals start with 3. And you can see that there's 3 of them, and that they're just basically the dumbbells in 3 different orientation. You can see your m is switching from 0 to -1 to +1. It should technically be m sub L, but whatever. And then you can see when we go from the 2p to the 3p, same thing happens with the spheres. Basically, you're just getting kind of a layering of these spheres. So there's just more and more and more of them. Don't worry, you'll only ever be asked to draw a 2p orbital. So none of these kind of crazy things. Next up, we have the d orbitals. So you can see there's 1, 2, 3, 4, 5 of them. And you can see they all kind of look like these 4-leaf clovers, except for this middle one, which is kind of a dumbbell with this kind of Saturn ring inside of it. You can see there's no 1d, there's no 2d orbital. just as would be expected. And then when we go higher up, we get this kind of layering effect. Same thing, right? Looks pretty cool. Play around with it. Don't worry, you'll only ever be asked to draw a kind of simple one of these 3D orbitals. And then finally, we have the f orbitals. So you can see it kind of looks like this one's a pretty good picture, like two d orbitals next to each other. But you can see there are some other slight other variations. There's 7 of them. You can see that clearly. And you can see we can go higher and higher, right? It's basically just comboed 2 f orbitals. So play around with these pictures. Think about what the values of n are, and if your n is equal to some number, what are the allowed values of L? What does that mean? What are the allowed values of m sub L, and what does that mean? What is m sub S? What does that mean? So really take a good understanding of these periodic tables, or this periodic table. Here's just another picture, basically, of these orbitals. Right, same thing here, just solving the hydrogen wave function to get these different types of orbitals.